Alright, this is our review of our study guide for today. It's Thursday, February 11th. We're going over mostly identifying functions. Numbers 1 through 9 we're just following the vertical line test and X repeating test. The other 6 are actually the real hard ones. My advice, if you did really well and got a 100 and didn't have any questions, you can skip this whole video. You're done. Bye. Have a good day. If you did miss a couple questions here and there, skip around in the video, go to the questions you missed, but regardless of how you did, it would probably be a good idea to review this video at least for those last 6 problems, numbers 10 through 15 or 16. So that'd probably be a good idea because those last few problems do get a little tricky. On to the review. Number 1, we are asking which points represent a function. That means that the x value, the first coordinate, cannot repeat itself, which is exactly what option choice A is all about. B, no. The x value repeats itself once here. For this one, I see 2 positive 2's, and for this one, it looks like all of them start with positive 4, so that's out. For number 2, this one was simply asking what about these values makes it a function. The correct answer is that the x value is paired with exactly one y value, meaning the x value cannot have 2 separate answers. That is what makes it a function. Now, these other 3 things are true about these sets of data. Okay? Just because all 3 of those are true, though, none of those explicitly are what makes it a function. The thing that makes it a function is the fact that the x value is paired with exactly one y value. For number 3, same as number 1 but in table form. We're just looking for which one is not a function, so we're trying to find the one that the x value is repeating, which is answer choice A. The x value repeats throughout the entire table. The other answer choices, the x value does not repeat at all. And before you're asking, it does not matter if the y value is repeating. It is allowed to repeat. For number 4, which graph represents a function? This is that vertical line test. You should be able to draw a vertical line anywhere on these graphs and not have them cross. Which, if I do that here, it fails. It did not pass the vertical line test. Option B and C, same deal. I can draw a vertical line here, and that will cross the entire thing. You can draw a vertical line here, and that crosses twice, so it's not those 2. This one, although it's weird that it is just flat horizontal, it passes my vertical line test. I can draw a vertical line anywhere on this graph, and it will not cross that line. So that works. For number 5, a table with missing values is shown, and it's asking what value could I put here that would make this be a function, meaning we need a value that it does not start with 7, 3, 1, or 9. Well, the only option choice left is 2. Has to be 2, 7. If I plug 1, 8 in there, well, 1 has already been used. I can't have another value for y. 7 has already been used, and so is 9, so we don't have any options, really. Number 6, we are asking, they phrased it differently, don't let this phrasing scare you. In which table is y a function of x? They're just asking which one of these is a function. So for this one, 0 repeats, so that's out. -2, -1, 0, 1. That works. That's okay. That is a function. This one, we got 1 and 1 again. And this one, we got -1 and -1 again. So that won't work. For number 7, in which table is y a function of x? Same phrasing as the last problem. Let's see. I don't see x repeating in this already. -3, -2, -1, 2. No repeating. So that works. We'll go to number 8. Number 8 and 9 are just like the last 2 problems. The only difference is it's not a table, it's a list of coordinates. So, which set represents a function? 1 was so close, but sadly, 1 repeated twice. For b, -3, -2, -1, 0. There we go. For number 9, which set of ordered pairs is a function? Well, I see the 1 repeats, so that's out. I see the 3 repeats, that's out. -3, -2, 0, +2. That checks out. That works. Now on to the last part. Those first ones, yes, I reviewed them very, very quickly. There isn't a whole lot to it. Draw a vertical line for the graph and see if a number repeats. That's easy. I could give any of that stuff to the 6th graders and they'd be fine. It's these last few problems that are going to be a problem. Starting with number 10. Number 10, Jordan compared the equation y equals -3x plus 4 to the line in the graph. So right away we have 2 functions. One of them is right there highlighted. The other one is in the graph. The graph is not showing this function that I highlighted. That's something different. The question is, what is the difference between the slope of the graph and the slope of the equation? Well, finding the slope of the equation is a no-brainer. After all, I've established this many times. Y equals mx plus b. M is the slope. Whatever that is, whatever the coefficient of x is when your equation is in this form, that's your slope. So my slope is -3. So we have that. Now, for the graph, we have practiced a ridiculous amount of times finding the slope of a graph. So that's what we're going to do. We're going to find the slope of this graph. So I've got a coordinate here I can use, and a coordinate here I can use. We're going to go ahead and draw these connecting lines. Sorry if the recording seemed to jump there a minute. I had to check my phone and see what that call was all about. Anyways, so we've got our slope here. It looks like it has a rise of 1, and it looks like it has a run of 2. Rise over run, 1 over 2. My slope for this graph is 1/2. So we have a difference of -3 and +1/2. That is what you are finding the difference of. You are finding the difference between -3 and +1/2. Now, if you make the mistake of just doing +3 minus 1/2, you're going to get 2.5, which is incorrect. That's wrong. This is a -3. -3 minus 1/2. That is basically the same as saying 3 plus 1/2, if I am finding how far apart they are, if I'm finding the difference between them. So, in actuality, it's going to be 3.5. And for those of you who don't believe me or say that's really confusing, you can do it a different way. There is another way. Use this graph. We're finding the difference between -3, which is right here, and +1/2, which is right here. How far apart are they? Count. 1, 2, 3.5. There's always multiple ways to do these types of problems. So if one way isn't working for you or one way is too confusing for you, try another way. Use these graphs, okay? For number 11, Amy compared function 1, which is y equals 3x plus 10, okay, and function 2, which is represented by this table, okay? So again, we have our function here, and we have a different function represented a different way. Which statement is true? We have practiced actually finding slope. That's the rate of change. We've mostly used it to identify if something is a linear function, though. But it's the same. You're looking for, with these being your run, the x value is going side to side, so the increase there is your run, and the increase of your y is your rise. Y-axis, of course, going up and down, it's vertical. So, for my run, we're looking at how much is it increasing each round. It looks like we are increasing by 1 at a time. So, for this, for my run, from one space to the other, we are going up by 1. For my rise, for example, it looks like we are increasing by 6 each time. So, plus 6. All we have to do is put that in rise over run form. 6 over 1. 6 over 1 is my slope for this equation, but, I mean, obviously we wouldn't leave it as 6 over 1, we would just say it's 6. So function 2, this table, has a slope of 6. Versus function 1, which we have highlighted here still, that has a slope of 3. All we have to do is look for which of those statements below matches this scenario. A says the slope of function 1 is 3 greater. No, the slope of function 1 is 3, but it's not greater than the second one. B has the same problem. It says that it's greater than 2, and that's just not right. Function 2 is more, has a steeper slope than function 1. C says the slope of function 2 is 3 greater than the slope of function 1. That is correct. 6 is 3 more than 3. That's that. Let's move on to number 12. Number 12 is almost exactly the same as the problem above it. For this one, we have one function. Talking about slope again. So it has one function with a slope of 2. I can go ahead and write that now. And this one, we have to figure out the function. So first, what is the x increasing by? Now, the x looks like it's increasing by 1 each time. So I can just go anywhere. It's increasing by 1 each round. How much is it increasing by the y each time? It's a little harder to tell because we're dealing with negatives, but going from -7 up to +4, that is an increase of 3. So it's going up by 3, so that's +3. So my rise is 3 and my run is 1. Well, that's going to be 3 over 1. I'm not going to write it multiple times this time. We're just going to say the slope is 3. So here's my information. We have function k, which has a slope of 3, function j, which has a slope of 2. My answer choices, A and B, both of them say that function j is greater than function k, and that's wrong. Function k, we can see, has a larger slope. So option choice C says the slope of function k is 1 greater than the slope of function j. That is correct. So there we have it. Moving right along, the last few problems, I do have to apologize about something. There's something I need to clarify. There is a difference between questions that ask if something is a function versus asking if it is a linear function. Now, both of them are going to have a case where the x value does not repeat. However, if it's asking for a linear function, it is asking, does it follow a rule like number 11 and 12 does, in that they are increasing at an even pace. This left side increases by 1 every time. The right side increases by 6 every time. That's what we're looking for when we deal with these functions. So, for example, this first one, option A, from -2 to 0. So we are increasing by 2. Okay? So if that side increases by 2, how much is this side increasing by? We're going from +4 down to 0. Well, that's minus, so we're subtracting 4. So this should happen every single time in that table. If that changes at any point, then it's not an answer. So we have +2 and -4. So 2 to -4, that's my ratio. So let's see if that keeps up. 0 to 2. Yep, that still maintains +2. 0 to +4. Did we subtract 4? We did not. So this is not a linear function. This one is out. That's how we're identifying these. We're looking to see, does the pattern maintain itself throughout the table? So this side, it looks like we're just counting by ones on the left. 0, 1, 2, 3. So that's just adding 1. How much are we increasing on the other side? 1 to 2. So again, we should just be adding 1 every time. So that's adding 1. That's adding 1. So 2 plus 1. It's not 4. So this table also does not work. That is not a linear function. It breaks its pattern. Let's check the last two options. The last two, we have 0 to 1, so that is plus 1, okay? And then from -1 to +1, what increase is that? That is plus 2, I think. Yeah, so when we increase by 1 on the left, we increase by 2 on the right. So on the left, it switches it up and we increase by 2. Now, that's not necessarily a bad thing. Changing what you're counting by, that's okay. It doesn't mean that this is not a function. That's not one of the things we're looking for. Remember, we're looking for a ratio change. We're looking for 1 to 2 to become something different. So if this side doubled, if we went from like adding 1 to adding 2, this side should go from adding 2 to adding 4. It should also double. It should be proportionate. So I should be adding 4, and I should get 5, and I did. So that works. That's okay. This has maintained the same ratio. Then we go here, 3 to 4. It looks like we're back down to 1. And we know if we're adding 1, we should be adding 2. Let's check. Adding 2, yes, that does check out. So the counting is weird, but that's not one of the things that would cross this out from being a function. As long as that relationship between the left side and right side of this table is maintained, it works. So answer choice D or C is what we were looking for number 13. For 14, which one is not a linear function? Take a peek at your notes, because I did write 3 things that must happen. First of all, x cannot be the denominator. This one is close, but x is the numerator there. We're okay. That is just x divided by 5. That's normal. That's okay. That is going to be linear. The other thing is that there can't be any exponents. X cannot be an exponent, and it cannot be part of an exponent. And that violates this rule already. So which one's not a function? That one. X squared, that's going to mess things up for us. For option choice C, which equation is a linear function? So again, we're looking for something that x does not have a exponent and isn't part of one. So we can already cross 2 things off. Can't be that and it can't be that because those have exponents. But then I don't see a denominator. So there has to be something that we're not noticing yet, and it happens in part B. See, this, while it's okay, we would like to rewrite this, wouldn't we? We'd like to rewrite this so that it's in that slope-intercept form, or y-intercept form. Y equals something x plus b. That's what we're looking for. So we'll use distributive property to get this out. So we'll do, let me draw an arrow here, y equals 3x times x. That's where the problem happens. 3x times x. If I say x times x, I should just go ahead and write x squared. And that automatically causes my problem. It can't be b because when I use distributive property, I'm going to get an exponent. So, for number 15, the answer should have been C because when we do distributive property, option choice B is going to get me an exponent. And that's not something we want when we're dealing with these problems. The last problem, asking for which of these is a linear relationship, it's the same kind of problem as I believe number 12 or 13 was, which is we're looking for common increases. Okay? The slope should be constant and unchanging. So for example, option A, it looks like the left side increased by 1 and the right side increased by 1. Cool. So it should be a 1-to-1 ratio. Whatever the left side increases by, the right side should increase by the same amount. So this time the left side increased by 4. That means the right side should increase by 4. That's not what happened though. Instead of adding another 4, we multiplied it by like 7. So already this table is out. That doesn't work. That's no good. Option C, from -2 to +1, that's going to be, or sorry, to -1, looks like we're adding 1 at a time. And on the left side, we went from 0.25 to 0.5. So it looks like we're adding a quarter each time. Okay? So for every 1 increase on the left, we only increase the right side by a quarter. So then on this side, we go from -1 to +2. That's an increase of 3. And let's see if, so if that multiplied by 3, this should multiply by 3, which means I should add 0.75, 3/4, to 0.5, which is not going to be 4. So this table is out. Next up, we have this one. Now this one, it looks like it's counting a little odd as well, but let's check. We've got -4 to -1. Well, that's going to be an increase of 3. So this side increased by 3. This side, we go from -11 to -5. That is an increase of 6. From -11 to -5, that's going up by 6. Okay, so if the left side goes up by 3, the right side goes up by 6. Keep that in mind. This side, it looks like from -1 to +2, that is an increase of 3. So that means the right side should still be increasing by 6, and it does. So already, this is better than the other answers. And I'm going to tell you right now, the answer should be C. Because if I go from 2 to 3, that's only an increase of 1, but that's not a huge problem. That just means we're moving a third as much. So if this side, my rate of change has changed by 1/3, that means this way should change by 1/3. So 3 divided by 3 is 1, 6 divided by 3 is 2. I should increase by 2. I should. And I did. It just has to be proportional. You see how 3 to 6, that is a ratio. Simplified, 3 to 6 is 1 to 2, so that works. As long as they are equivalent ratios on both sides, it's good. Option D doesn't have that happening. Option D, we increase by 2 here, so add 2. 6 to 10, that is adding 4. And then we go from -2 to +3, which that is an increase of 5. So why did this one start decreasing? That shouldn't happen. Okay, 2 to 4 is one ratio. It shouldn't suddenly become 5 to -6. That's wrong. That's how these types of problems are meant to be done. Alright, so let's check and make sure that there are no errors with the study guide. It should say 16 out of 16. Good. So there we go. That is our study guide for this. And, well, that's all. I hope it helped, and good luck later. Bye.